you're working with WAM, in the modeler in the preview, it's all going fine. You have a little bit of data in your preview. Anything you do just works fine. Then you publish, go to staging, still fine. Go to production. People you don't know start adding data. The number of records increase into the thousands, into the millions, and then things starts to slow down. What Gijs has been trying to explain to you is that there is this part where you work with the database and you can have different kind of expressions that work against the database, and some of them are fast and some of them are really slow. And especially when the number of rows is small, you don't see very much difference and you can live with it. But as soon as it starts to grow, then you see the difference. And then, when that happens, you need to understand a few things, how to improve your application's performance. This is just the starting page of the project that we will deliver to you using the MyWAM App Store. A few things that you need to be aware of is check your loops, they can be slow. Check your filter expressions, they can be slow. Check your sort definitions, they can be slow. Also, mind the request and the request response workings of a web-based application. The user starts a request, server starts to work on it, provides the response and sends it back. But you're not alone. There are very, very, very many users on your applications, usually, if you have a very high available application. So if you have an application and it starts a request that takes long to finish and it accesses the database, you might create a database lock and it will create a traffic jam. Other users will be trying to find something in the shop as well that you were just updating in a slow way, and they will just not get any results. I will get to that in a bit, one of the next slides. Also, one of the things that we usually say is that if you have data processing flows, like large imports, be aware of the fact that if you do that during office hours, that other people are using your application as well, you might cause traffic jams. So if at all possible, try to do work like that, massive updates of your data, try to move that to out of office hours periods using scheduled tasks, cron jobs that are available. Let's see where I am. This is the start page of the application. Okay, so the examples I'm going to discuss are some query comparison examples in a slightly different way than Gijs did. And I'm going to talk about some batch processing and an activity called loop versus export import. So let's do some query comparison examples. I can just go here, some examples. Okay. While you're looking at the loading screen, I'm doing a few things. In this page, I created an overview of all cities, and the city has a date end and a date start. I just added some simple data using some functions, random functions, to create a year that is very different, and it ranges from way back when to way back way up in the future, just to get some dates in and to work out if I can filter on the year where the year is smaller than, just for instance, 525. The problem with this is, as Gijs told, this is one of the examples that is not SQL compatible because it uses the date diff function between the city date end and the city date start to calculate the difference in years. So how can you create a solution for this to improve its performance? The solution is not in creating a different expression using still the date end and the date start, but the solution is to calculate the difference when the row of the city is updated or added. Because you know, because you are in control of how your application is working and why it is doing the things it needs to be doing, you can say, okay, I need further down the road, I need a filter on the age of a city. So this is the easy way. You have a date end and a date start, you calculate the difference in Hoppakee. You just wait until you get the results. Fine. But what you can also do is just store the year, the age, as a specific field when each and every row of the city is updated. Because at that time, you are already updating the data in the database. Calculating the age at that time is cheap. I also showed you, like Gijs did, the time stamp on the page. And as you can see, we have a difference from 55.7 to 57.7. It's 2 seconds for 31,000 rows. The next one, where I just use the age that I have calculated when adding or editing, managing the data, using that query expression, gets from 57.7 to 59.6. That's not right. Oh, yeah. I clicked on something. I need to do it again. Just hold on, please. I did a sort. You do not do sort. Not like this. Because it was working with the same, this page is rendered in one go, doing the first slow data grid as well as the second fast data grid. So now I've just created a new fresh page, and you see 3.4 seconds until 4.8. So that's a bit better than it was before. It's 1.4 seconds, but the difference between 4.8 and 5.7, it is faster. Why it is? When I did this before, the difference was a lot bigger. So something.
So in the meanwhile, web has improved.
No. The second one should be a lot faster, but demo ghosts are always there. Trust me, I will say this only once.
Someone else do an import. What is the
Yeah.
difference when you store age as a calculate? Because I see it also be slower.
There's one thing wrong with your expression. That is, you say, what is the difference when you, at least, you were talking about storing a calculated field.
Oh, it's all stored.
Calculated fields are never stored. Calculated fields are only a placeholder for a function or a calculation that is executed at the time that you access it. And that's a very dangerous one. So actually, if you have a calculated field, you will still be doing the date diff calculation at that point. And this is a calculation that needs to be executed for every row. And this is just a basic, should be very fast filter. But maybe something else is on. But anyway, the sorting is still on, yeah. Let's do what Gijs says because he's smart. Let's look at the numbers again. 24.3, 26.9. That's very good. It's very good. It's 2 seconds, 2.6 seconds. And then you have the difference between 26.9 and 27.1, which is a few tenths. This is what I expected it to be. So, yeah. Having this bit of information that you can define because you know that in your process you need this bit of information. Make sure you get to that bit of information the cheapest way possible. Calculate it when you can and use it when you need it. Next up is a different way, a different example of what Gijs also has displayed before. Kind of. When you are searching for items that are a reference field, but you want to look for a certain property of that reference field. For instance, the city, we are looking at cities, and cities have a reference to the country. But you want to filter all cities based on the fact that they exist in a country with something called land. Okay? The easy way, what you would do, is just like this. You are looking in city. Oh, you have the country, that's a reference. You do the dereference and find the name that contains land. There is a better way. And that is also what Gijs a few times has displayed. Use the in construct, ID in list. What happens, I'll show you the numbers first. This one is 24.7 and it's ready at 26.1. So that's almost 2 seconds, 1.5 seconds. The next example, what am I doing here? Instead of working from the city list, which is big, bigger than the country list, instead of using the city list and finding the corresponding land by name, I'm doing a filter on the country list, which is a lot smaller. I filter that based on land because a string comparison, a string contains, can be very expensive. So if you do that on the smallest list that you have, and you limit that result list, and then you get the country and you compare it to the resulting list of IDs that match the land, it's much faster. 26.1 to 6.2. It's a tenth of a second instead of more than 1 second, 1.5 seconds. And again, as Gijs also said, the difference between a few tenths or just a few seconds, it's not that big. But it gets bigger in a linear way or even an exponential way as soon as the numbers in your rows hit the thousands, hundreds of thousands, millions of records. And then these are the items that you will need to look for. Any questions so far? No? Great timing. Alrighty then.
One thing, the contains keyword is also translatable to SQL for this one purpose. This means that only one in the bottom, that the filter expression is also translated to just one SQL query.
I've got another example in the string number compare. A lot of filters are done with dates. The problem with dates is how to match them properly, because you have different formats, especially if you are using Excel imports and you are getting Excel imports from different users. Some may have English US language, some may have the Dutch language. So all these dates are in different formats because Excel doesn't provide you with one field that or one date format that is always the same. No, you get it from Excel in the formatted language. So that's very difficult. So when you want to compare dates, you've got a bit of an issue. You can use functions to make sure that the input you get is handled and that you can just compare dates directly. In this case, I'm just going to do a few simple things using date comparison with either strings or numbers, because these are actually some examples from real life. Customers presenting me with, why doesn't this work? And that's why I just put them in, because I'm showing it to you now. This is how somebody created a function to check for the date. And he wanted to make sure that the string that comes in is in this format. So this is the Dutch format. Dates that are stored in SQL in WAM projects are not stored within with the Dutch language. So you cannot directly match them unless you do some additional formatting using the language. But that would mean it's a function, it will be slow, etc. if you do that directly inside the expression to filter a large set. So what happens here is you have it to string, date, part, day, month, year, combine that, etc. and then filter it if it contains the same date. Let's see what the numbers say. 13.2, 16.3. That's 3.2 seconds, 3.1 seconds. Okay. Another way to work, just to compare, let me just, this one is quite old, I think. How did I do that? Yes. Not sure why I put this in, but the best way. The final words of the final solution I created is again, if you are aware of your data and how you need to create your filters, you are allowed, and you are in control, create your additional fields that you can store and make sure that your filter queries will be optimal. So what I did was also, again, added specific numeric fields for the start day, the start month, and the start year, so I can directly compare them using the 1605 and the 1915. This way of very concrete fields and data, it will give you extra fields in your data model, as I will display. This is the city table, and here you can find the age that I added, because in the end just the date end and the date start were the actual dates to work with. These are the given dates. The age is something that I knew I needed to filter. I added it. The dates, start day, month, and year, I added them. So I can optimize my functions. So if I just find the usage of the age, and then I can go into this flowchart. This is where I loop over a city, and then assign some values. And what I was doing is just some random between minus 2000, minus 100, and then turn it into a year, just to get some date in. And then I just updated the date start year, the date start month, the date start date, and the age. Just compare it, calculate it, and store. And this is just one update flow that updates all the works all the dates in the city, so that I have the concrete values and do not have to calculate them while filtering, because that is expensive. So that's the takeaway here. If you know your filters, if you know the need to filter, make sure that you have the data to optimize it as well. You can add extra fields and just update them when it's easy and use them in the filters when it's required and optimal. Then we have the batch processing. And now for something completely different. Yeah, not do that. The batch processing. It's nice when you have a big screen. I'll just start the processing. Remember, I was talking about doing a lot of update and import and stuff like that, and you might be working on a large list that will take minutes, hours to process. You need batch processing. You need to chunk it up into smaller bits. And if you think about the response request system behind a application, a web application, normally when users are using a page, okay, 10 seconds start to feel very slow, but 10 seconds for an update, that's okay. While you are blocking the traffic, the shorter you block the traffic, the more space there will be for other requests to come in and be handled. So my golden rule would be keep long-running processes between maximum 10 or 20 seconds and provide some breathing space for other requests to be handled. How can you make this happen? You can either or use row counters, a row counter-based chunk or a time-based chunk to handle updates, pause, show update to the show progress to the user, meaning that you have a response service quiet, then automatically return a new request, and it will continue its work on the server. The additional plus is that you can display your progress to the user, and then this is also quite important. Do not wait until everything is done to to hit the Save All Changes node, because then you will just bypass everything that you have been working up to. If you, as soon as you hit the Save All Changes node, all changes working up to that node are in memory, and only when you hit the Save node, then all the queries that have been generated will be sent to the SQL Server and updated, executed. So in some points, you need to figure out what is the sweet spot. How many numbers, how many rows can I update while it's still okay to perform? Now, before I hit start, I will show you, try to show you what I'm going to do. I set the total working number to the count of the city. So I'm going to update all cities in this loop. I use a total working number, I use a counter, and I use a timer. Now, on each run through the loop, I just update the counter with 1, so I can count how many rows I've been hitting. For the time being, I do not, these are the fields that actually do the update into the database. I'll skip them for now, because they're not that interesting, but that is where the work is done, changing and creating the update statements. But the more important thing is, by the way, yep. Here's where the magic happens. The decision node. Here do I check if I'm using the modulo operator to see on each bulk of 100 records, I make a decision. And that decision is, if it is a multitude of 100, I show a counter. So this will send a response back to the user, showing how many records I've been hitting. Then I do some timer set to current time, and I do the Save All Changes. So in this part of the loop, I actually save 100 rows that have been changed. But if I've not been at a multitude of 100, then I'll just go following the default exit towards the city to continue the loop. At the end of the loop, I'll just show the final counter. I do a final save because it may be like you get to the end of the cities, but it's not specifically a multitude of 100. So you need to do a final save changes, and then I just do a reset of everything, and then I'm done. That show counter, let me just quickly show it. It's an overlay with a continue. Many of you will recognize this, I hope. The trick here is that you have the follow exit, which just provides a way to show result to the user and immediately send a new request to continue to the server. And as long as there is no new response back from the server, this overlay will be displayed. Okay.
This is a widget, by the way.
Right. Next, I will do something funny. So I've got my counter modulo 100. Let's start. And just wait. You see, numbers are going up. But I think, well, this is going to take quite a long time to do it in 100. So let's keep it running. Maybe 1,000 will work as well. Let's click OK. Hit publish. I'm working on the staging environment. So it's now publishing. Look at the number. It's still going. And now it's going into the thousands. Just like that. But the thousands, well, okay. I'm trying to find a sweet spot. Let's make it 3,000. Okay. And let's publish again. And go back to watching the numbers. Still by the thousands. Hi, and there it goes by the 3,000s. So this is just how you try and find the sweet spot, one of the ways. And then it's done. While you were looking at the numbers being updated, other users would still be able to perform normal requests and not knowing any different.
So what do you mean with the sweet spot? Is that just how long it takes to switch? If that starts to take 10 seconds, then you're like a little more up.
Exactly. You want to be in the area of 10 seconds. That you want to keep the traffic jam as short as possible. And between 10 and 20 seconds is usually okay to keep everything going.
Yeah, but this is so fast that it...
You also don't
Exactly,
want to refresh it too many times,
Right,
because
Yeah.
that also creates overhead.
Yeah,
Yeah.
this is actually the opposite. It actually takes longer because
Yes, in the end, the whole process takes longer,
Yeah.
but your application is still responsive to everybody else who's using it. That's the main idea here. It's not to make your process for bulk updating your system. No, it's to make sure that everything else works, still keeps working while you're doing it.
But they can go hand in hand. I remember doing a test myself once and figuring out, do I need to save often or can I use large chunks?
Yep.
And also in that case it turned out that somewhere between 10 and 20 seconds was the ideal moment to do in-between saves for the entire process to be as short as possible. So even for my own process, that turned out to be the best solution.
Yes, it definitely is worth finding that sweet spot. And this example just gives a very basic example of how to do it. So use it.
Now, because you're saying batch, then I have to think of cron jobs. If you're running it in a cron job, there's no interaction. So does that just take up, can that stop everybody else? Or does that work on a different level?
That works on a different level. Using cron jobs is usually when you want to start some flows without being in control on your website, on your application. So you want to use scheduled tasks, cron jobs, to start jobs that can be scheduled during the night.
Yeah.
And currently, we have the external EasyCron solution, which actually also has the HTTP response timeout. So if you have a cron job and you use our current solution with EasyCron, you need to make sure that your job runs within 2 minutes. If it exceeds 2 minutes, the job will time out actually, and you will not get the guarantee that everything within that job is finished properly. So you need to do a different way to chunk that up and make sure that.
You keep track of where you are and stop and start
But
again.
we are working on a very new solution, kind of like native scheduled tasks within WEM. And we will be providing a different way that those scheduled tasks are run. They will not be running using the HTTP traffic. So there will not be the 2-minute timeout. It will just run on a different thread. And we will do some extra optimization for that. This is still in the works, not available yet, but we will communicate when it will be available. Yeah?
Another way of batch processing is using offset and a limit, for example. So you can say, okay, first I want to process
Mhm.
and the next time I want to continue at record 101.
Mhm.
And now when we create something like that, in the second run, you just skip, you look to the same data set, and you skip the first 100, and then you continue at the next one. And when you go further into the data set, with 200,000 records, there's one time that you can say, okay, first skip 150,000 records, and then go to your next batch of 100. Is there something, because you don't have a sort of record row or number in your in web, are there different approaches there?
Yes. I will repeat the question first. You want to do kind of take and skip,
Yes.
and be able to just define the number of rows, like 1,000. You want to do the first 1,000 and then leave it, and the next run you do. This is actually what you should do when you need to chunk it up using the unattended cron jobs.
Yes.
However, it is the way you describe it, that the next time you go in, you want to skip the first 1,000, or you want to skip the first 200,000. And that is something that you need to work out with your own administration. We do not have an easy skip and take on the list in expressions. So what you would do is just have a separate list where you keep record of where you were the last time. And if you know, you can store the ID, the row ID. And if you make sure that if you run through the list, sort it by ID, the numeric ID, that is the primary key, which is the fastest to sort and go to. So you would make a manual skip and take, but you would go to the last row and then run through another number of rows.
Is it also possible to use it in an expose API?
Yes, but again, it will take some administration of your own that you need to say.
That's fine, but if you can use that administration also in an API, that would be
Yeah, because you are storing it. You need to store it in a persistent list,
Yes.
so that you can access it in every session that you need.